All right. Section 10.2, we are going to be talking about triangles. Okay. Problems involving angle relationships in triangles, similar triangles, Pythagorean theorem. All right. Triangle, the definition of triangle has three sides, and they all lie on a flat surface or a plane. It is a closed geometric figure. So when they're talking about a closed figure versus an open figure, if, for example, I draw that and stop, that would be an open geometric figure. If I draw three sides and I go back to the beginning, then that is a closed geometric figure. Okay. Okay. Given a line and a point not on the line, one and only one line can be drawn through the given point parallel to the given line. So what does that mean? All right, so I have a line right here. Line. And I've got a point that is not on the original line. And Euclid's assumption, this is actually, nobody's been able to prove this. So we assume it to be true because we need it to be true. There is exactly one line that is parallel to the original line that goes through that particular point. There you go. Essentially what it's saying is these two lines are parallel. Okay, so now what we're going to do is we are going to take this point and our original line and put 2 points on that line right there and connect them here and here. In other words, we're making a triangle. But this original line, or sorry, this is the given line. But this line right here, the one that goes through point B, it has to be parallel to AC. Okay, and if it's not parallel, this whole thing kind of doesn't work. So because these two lines are parallel, we know that angle 1 has to be the same as angle 2 because they are alternate interior. Keep in mind, I could extend this, right? That's a transversal. So angle 1 and angle 2 have to have the same measure because they are alternate interior angles. In the same way, angle 3 and angle 4, so here we have another transversal. So angle 3 and angle 4 also have to have the same measure. Now what happens when we take angle 2, angle 5, and angle 4 and add them up? Well, they add up to a straight angle. They are all supplementary, which means they have to add up to 180 degrees. Because these angles have to add up to 180 degrees, that means that these angles must add up to 180 degrees. Long story short, the sum of the measures of three angles of any triangle has to equal 180 degrees. All right, so we are trying to find the measure of angle A right here. We know angle B is 120, and we know angle C is 17, and we don't know what angle A is. We're going to call it X, and we know it has to add up to 180 degrees. So we are going to solve this equation. We're going to combine these. 137 equals 180. We're going to subtract. See if I can do this in my head. Probably not. This has to be 143. No. How about 43? 43, that would be 10. Yes, it's looking like it should be 43 degrees. Yep. Okay, so we need to find the measures of angles 1 through 5. Whenever you're given a situation like this, what you're going to do is see if you can find any of the triangles where you know 2 of the 3 angles, okay? This triangle, they did not give us 2 angles. This triangle, they also did not give us 2 angles. However, they did tell us that this angle right here is 90 degrees. Okay, so because these 2 angles right here have to add up to 180, that's a straight angle, they're supplementary. That means angle 1, the measure angle 1 has to equal 90 degrees. All right, from there we can find angle 2, because now I know 2 of them. This one has to be 90 degrees, and this is 43. So 90 plus 43 plus my angle 2 has to equal 180. 133. Let's see how good I am at mental arithmetic. And we're going to subtract, and we get 47. Isn't that the answer to the last one? Let's see, 10. Yeah, 47. All right, so now that I know angle 2, comma, measure angle 2 is equal to 47 degrees. I can find angle 3 because these are vertical angles. So these 2 have to be the same. 2 and 3 have to be the same. So because they're vertical angles, measure of angle 3 is also 47. Okay, now I can find angle 4 because this is 60, this is 47, and so 60 plus 47 plus angle 4 has to equal 180. Let's use y. I don't want to use the same variable and get you confused. All right, so we combine these. 107 and subtract. And we get 73 degrees. Okay, so the measure of angle 4 is 73 degrees. And lastly, so this is 73. We can find angle 5 because angle 4 and 5 are supplementary. So 73 plus, let's call it Z, has to equal 180 because these 2 angles right here are supplementary. I just had a thought. Can you guys actually see my pointer if I do that? I'll have to double check. So that would be 107. So the measure of angle 5, 107. Now, let's see if my arithmetic is correct. 47 and angle 4 is 73, which I had, and angle 5 is 107. All right, we can classify triangles in a couple different ways. We can classify by their angles, or we can classify by their sides. So if all of the angles are acute, less than 90 degrees, then we call it an acute triangle. If one of the angles is 90 degrees, we call it a right triangle. Not sure why, but we do. And if one of the angles is obtuse, then we call it an obtuse triangle. To classify by sides, we talk about sides having the same length. So if we have two sides, wow, I wish I could erase, that are the same length, that's what these little hash marks mean, that those two lengths are the same. Then we call it an isosceles triangle. And by the way, the angle that's opposite the side, therefore, must also have the same measure. Okay, so if we have two sides that are same, we also have two angles that are the same. Equilateral, this right here, EQI, is a prefix meaning equal. And lateral refers to sides. So this literally means equal-sided triangle. So all three sides are the same, which necessarily means that all three angles are the same. And if no sides are the same, we call it a scalene triangle. And that's where I'm going to stop for this recording, and I will finish up this section in another video.